Now we'll proceed to our next session. Next session will be Introduction to Machine Learning by Mr. David Patrick. He's also a Microsoft MVP with 30 plus years of experience and also MCT since 2001. Wow. Yeah, it will be really good, and I'm excited to learn something from him also. So ML.NET is another hot topic in the .NET ecosystem. It gives us capabilities to develop machine learning or AI models inside the .NET application, and we'll see it how. So let's start, and please feel free if you have any question. Now I will share. So yes, Mr. Patrick, now you are live.
Awesome. Thank you very much. Appreciate it.
Thank you.
So welcome everyone. This is my talk, Intro to Machine Learning with .NET. My name is Dave Patrick. I'm a MVP, Microsoft certified trainer, subject matter expert. I work for a company called DSA Inc. So if anyone's interested, come check us out on our website, dsainc.com. I also teach at a couple colleges here on the East Coast of the United States. I'm a adjunct professor at University of Maryland. My day job, I work for the U.S. Army. I'm a subject matter expert. It means that they make me do everything. I also have taken a lot of Microsoft exams. As they mentioned, I've got 6 MVP awards. I've taken so many exams. One of my certifications is MCP DED. It stands for Microsoft Certified Professional Developer, Enterprise Application Developer, but I think it's funny, so I put that one up there. I also run a couple user groups, Baltimore Cloud, which you can find on meetup.com, and Mad SharePoint. Both of those are hybrid, so you can attend from anywhere in the world. A little plug for my company again. Great company, been around forever. Always looking for folks to come join us. And the meetup, if like I said, the Baltimore Cloud meetup, we're hybrid, so we've been doing hybrid meetings even before the pandemic hit. So we used to even use tools like Live Meeting to do hybrid meetings. All right, so what's the agenda for today? Really, not real basic things we want to get out of. We go over what machine learning is, why would you need it, some of the most important fundamentals of machine learning, models and training. Then we'll jump into one of Microsoft's offerings, which is ML.NET. We'll do a quick intro to what ML.NET is. They've got a tool in there called the Model Builder, so we'll look at that. We'll do a couple of demos, and then we'll see some reasons why we want to use these tools. So what is machine learning? Machine learning, a gentleman named Herbert Simon had a good quote that I liked. It's any process, or learning is any process, by which a system improves performance from experience. So not just machine learning, but learning is any process which a system improves from past experience. So machine learning is a machine doing that, right? It basically, and then Tom Mitchell's got a nice quote here. It's the study of these algorithms that can improve their performance, we'll call that P, at some task T with past experience, and we call that E. So if you look at traditional programming versus machine learning, in traditional programming, you had data, you had a program that worked on that data, and then the computer ran that program and produced some output. With machine learning, you've got the data and you've got the output from previous runs, and then the computer will run that program based on that output and get better at the task. So it's an idea of using that information from that was previously generated to get better at something. So when would we do this? What are some situations where machine learning makes sense? Because machine learning is not always useful, right? The bottom bullet point on this slide talks about there's no really reason to learn to calculate payroll. We know how to calculate payroll, right? That's a pretty standard formula. I worked 40 hours, I make $8 an hour, this is how much I get. So that's pretty straightforward. But what about some situations where we don't have the expertise? So like navigation on Mars, that's a situation where machine learning could come and could be very helpful, because we don't, we can't, it's not like we can go there and figure it out ahead of time. Once we get there, we got to start figuring things out, where to navigate. Or there's situations where it's hard to explain our expertise. So humans are very good at speech recognition, but it's hard to break that apart and determine the steps involved in doing speech recognition. So that's where a great machine learning has really come into play with devices like Alexa or OK Google or some of these things, Siri and all those. So machine learning is by looking at previous runs of speech recognition helps us get better at speech recognition. When we have to have models that have to be customized, like personalized medicine, when you have models that are based on huge amounts of data. So there's a lot of situations where machine learning makes sense because of these various situations that traditional learning doesn't, or traditional programming doesn't make sense. What's the classic example of a task that requires machine learning? Pattern recognition, shape recognition. In this case, which one of these is a 2? So even as humans, we find this. I know my handwriting is not that good anymore. It can be difficult. Is this a 2? Is that's a 2? Okay, but why? So machine learning can help us get better and better, as we've seen. There's some classic examples of where my phone now, I can point at something and it recognizes a shape. So machine learning has definitely come into its own with solving some of these tasks, and they do it by using different learning algorithms, right? So there's certain algorithms for recognizing patterns, whether it's a facial identity or a facial expression, whether someone's smiling or not, handwritten or spoken words, medical images, generating images. Previous speaker talked about the deep fakes, where you see these videos of somebody singing, even though that's not that person singing because they have no business singing. I don't know if anyone watches any of the Got Talent shows. So over here we have the America Got Talent, and one of the acts was showing the judges singing opera, and it was like, no way that the judges are really singing opera, but they used deep fakes to do it live, on TV, projecting the judges' faces on the actual singers. Recognizing anomalies, this is a good one. This is a very practical one, right? If I usually charge about $100 a month, and all of a sudden I'm charging $1,000 a month, or if, there's, instead of a $5 Starbucks charge every day, there's a $50 Starbucks charge. The machine learning can help to recognize those anomalies and say, hey, Mr. Patrick, I don't think you really meant to spend $50, or you didn't mean to leave a $100 tip. Maybe you meant to leave a $10 tip. And then again, of course, prediction, right? We want to know, and it would be great if we could really predict future stock prices. But things like, the weather, there's all sorts of different situations where machine learning can do a pretty good job of predicting what the next event might be. So some sample applications where machine learning comes into play, obviously web search. So if you're out there on Google or Bing.com or any of these web searches, they'll recommend different search suggestions. If you ever started typing in some text, it'll come up to try to finish your search terms for you. Additionally, it'll try to sort your search, the relevancy of your search based on previous searches. So it tries to get smart about the fact that I search a lot of geeky topics. So if I type peek and poke, I'm talking about memory locations and not playing a child's game or something like that. Obviously, computational biology, areas in finance and e-commerce, space. We mentioned navigation on Mars, space exploration, robotics, extracting information. So doing things like looking out over the web and pulling information from different websites. Social networks, debugging. I don't know if anyone's seen any of the demos from Microsoft where the Microsoft Visual Studio now will help you write your own code. So it'll actually make suggestions for the next couple lines of code. So debugging software. And then there's more coming, lots of different areas where machine learning is entering the sample applications. So let's talk a little bit about ML.NET. Basically, ML.NET is Microsoft's attempt to help for the .NET developers easily use machine learning, right? And there's two things that they talk about, models and training. So in the first top of this slide here, we talk about how do we build our model. We've got to use some data, so we got to collect and load some data, and there's a data view interface for that. We've got to create a pipeline from that data. We've got to train that model. There's a fit method we'll call. We have to evaluate how that model is doing. And notice it's a circular type pattern where the more time you can invest in it, the better the accuracy of the model. At some point, you do have to stop training it and say, okay, we're going to save that model because now we need to use it. And that's exactly what we can do in ML.NET. We can say, okay, we've spent enough time, we're going to save it. Now let's load it and let's create a prediction engine and start doing predictions. And we'll do a quick demo that walks you through some of this stuff. If you're new to models and not really sure, well, man, these models, and I'm training models, I'm loading data, how do they work? It really is, fundamentally decision trees, right? So here's a sample decision tree where it says, I'm trying to predict the price of a house based on the number of bedrooms. So if it has more than 2 bedrooms, it's probably going to be 188,000. If it's got less than 2 bedrooms, it's going to be, this is a very simplified decision tree, but typically a model would do something like this based on data, and then on more data, it would get a more complex model. So now we've got some more data, and we're taking into account how many square feet the house has. So not only the number of bedrooms, but about how much square feet, and then come up with additional predictions. And that's at a real basic level how models work. You read some data, using the different data points, you come up with different predictions. And the more time you spend building and training the model, the more accurate the model can be. So again, enter ML.NET, open source, cross-platform machine learning framework. Meant for the .NET developers. So there's tons of .NET developers out there. I work in my day-to-day job with a lot of .NET developers that are constantly looking for other areas to, we do a lot of SharePoint development. But if you want to dip your toe in the water of the machine learning arena, ML.NET is a great tool set to help you move from utilize your .NET experience, but then move into this new arena. It also has this thing called AutoML. We'll talk a little bit about that to make it easy to train and deploy different custom quality models or quality custom models. It can be extended with the popular TensorFlow framework, and by using the cloud, you can use you can scale out. So as I mentioned, ML.NET is built for .NET developers, and here's an example of some of the code, C#, you could use F# too, of what it would look like. And in a nutshell, it's really simple. It's these few steps. You create a machine learning context, you read the data in to train your data, you create your pipeline, train your model, make your predictions, and then actually do the prediction. So what are some of the things you can do? Sentiment analysis. So maybe you're looking at text from a tweet and you're trying to say, is someone talking, was that a good tweet or is that a bad tweet? I think one of our demos, we actually look at restaurant reviews and try to tell if it's a good review or a bad review. Product recommendation, price prediction, grouping your customers, customer segmentation. Object detection is a great one where you can actually, hey, is there a person at my door? Did they leave a package? Fraud detection, we mentioned, whether a transaction might be valid or not. Sales spike, image classification, sales forecasting. So really lots of different scenarios that ML.NET can help you with. So let's do our first demo. This demo is using ML.NET and just real basic, console app to read data in about flowers. We're measuring petal length about iris flowers, and then based on the length, the different lengths, different measurements of the flower, we're going to determine what kind of iris flower it is. So what I like to do is I use these tutorials from Microsoft Learn, and if you haven't looked at Microsoft Learn, you really should. I'll talk more about it near the end, but it's more than just documentation. It's hands-on labs, tutorials. I can't go on and on and say enough good things about Microsoft Learn. So let's look at this particular demo. So we're going to go in here to this particular demo and kind of get an overview of what we want to do. Again, it's going to build a clustering model based on this iris flower data set. We're going to hard code the machine learning task. Later, we'll do another demo where we kind of dynamically figure it out. But we're going to do an unsupervised machine learning task because we're not sure which of the outputs we're going to put the particular flowers in. We'll create our console app. So Visual Studio, we are .NET developers, so we'll bring up Visual Studio, the latest version. It is important you match the right versions. When I first did this demo, I actually had the wrong version and ran into some errors. And for this particular demo, I left a couple of errors in just to show you where things can possibly go wrong. The tutorials are not always the best at showing you what things can go wrong. So I'm over here, I'm just doing a quick console app to house my, which is the old DOS command window type app. Just to keep things simple. You could have done a Windows app, you could have done some other types of apps, but just to keep things simple here, we'll do the console app. We will give it a name. So this is the flower demo. And then choose .NET 6. That's the version of .NET 6 that we need for this particular, to support the ML.NET. Go ahead and generate our code. And then once we generate our code, what we're going to do is we're going to go add to it, right? We're going to add, we're going to load our data. We're going to install ML.NET if we haven't done that already. So there's the sample, program that Hello World everyone gets when you first create an app. So we're going to need a folder to hold our data. So we'll go in there to the Project Explorer and create a folder for our data. Let's go out to our Solution Explorer, right click in there, create a folder for data. And it is important to put the data in the data folder. I think I do that at first, but you'll see one of the mistakes I made doing this is moving the data out. I fix it later, but just to give you a heads up. So, okay, we need to install ML.NET. So we'll go over to our manage NuGet packages and make that part of this project. So I got to go over there to my under Project Explore, manage my NuGet packages, and go find the ML.NET package so I can install it. So go look for it in there. It's not installed in this particular example yet, so I'll go browse out there. I find it, there it is. Let me go ahead and download it. It's not very big, under 3 megabytes. Grab the latest version. That's the version the tutorial said that I needed for this example. You can see some of the pieces and parts that belong to it. I've got, of course, agreed to the license acceptance, which I've never read. For all I know, I've signed away my house and my firstborn child, but that's okay. So we go and we install ML.NET. We've accepted all the user agreements. Now let's go grab our data. So this is the Iris data set. They hosted it out on GitHub. So if you haven't used GitHub, I just want the raw data. I'm going to go and download the data from the raw link. That will just give me the data. So I've done that. There it is, iris.data. I'll go ahead. I'm doing it again just to show you how pull that down. So we'll go ahead and pull that data down. And then from there, now that we have the data, we can go out there and copy that into our project. And again, I need to put it in that folder, so that we bring it up and give you an idea. So these are, again, the petal links, each one of those comma separated. And then this particular data set has the resulting grouping. We're going to use that to train our model. So let's go ahead and take that data set and add it to our data folder inside our project. And again, the tutorial walks you through step by step each step you need to do. So it's pretty easy to follow through. I actually use this in a lot of my courses where I want my students to perform these exercises. These tutorials are very thorough and straightforward enough that I can give them to my beginner students. So there I just went into my data, I copied it from the file system, and now I'm just pasting it. So it's in the folder. That's where it belongs. I think I accidentally move it later and then I have to put it back. So just one of those things to watch out for as you're walking through the tutorial. It's one of the things that can go wrong. And again, it just gives you a little information about the different measurements that are in there, the result, the type of the iris flower. So now in order to use that, I am going to need a class to represent that data. So I'm going to go just add a class. And what you do in that class is you're going to specify the different attributes, right? The different measurements. So I'll go ahead and add a new class. And then I think you also have to have an attribute for the output. Call this the iris data class. Give it a name, click add. So there, it's just right there. I think I didn't mean to do that, but I moved my iris data out of the data folder. So we'll fix that in a minute, but that's just, I just did a little drag and drop by mistake. All right, so we need to add a using statement to say, hey, we are using ML.NET. So we add that. The next step is to go in there and add those attributes I talked about. So for the sepal length and the petal length and the width, and then for the actual prediction, we need the predicted label and the score. So it's really two classes. We added a single file, but inside that file, we're adding two classes, one for the actual iris data and another for the prediction, the cluster prediction. So once we feel good about those, we save that. I'm looking at there, some of the using statements are grayed out, meaning I didn't use them. That's okay, it's not gonna hurt anything. It talks a little bit about the load column that we added to our class, the predicted label, the score, and what we're doing with those and what the meaning behind them. The next step is to go in and define the data and model paths. So we've got our class for the flower data, we've got the actual data, but we need to load that data into our program so that we can utilize that data, right? So that's what we're going to do next. We're going to create two variables, data path and model path, and the first one to our iris data, and the second one to our model that we haven't generated yet. So that second one is pointing to a zip file, which is going to represent our model that we have not yet built. We're going to build it, but we haven't built it yet. That iris clustering model.zip, that's going to be built. So now let's write the code that's going to build that model. So the first thing we need to do is say, hey, we're using ML.NET. The next thing we're going to do is create that ML context. For any of you who have used like entity framework and database context, it's a very similar thing. So we just say, hey, we need this context. Next, we're going to go and load the data. We say, okay, this is where the data lives. This is the separator used in the data. So we use that data path that we just set up earlier. Now we're going to create that learning pipeline. And I mentioned we're hard coding. We're choosing the model. So we're going to use the k-means trainer to train the model using the k-means plus clustering algorithm. The next demo will actually dynamically figure out the best model, but this one we just said, hey, we know that this model is the one that we want to use. I shouldn't say model, but the algorithm that we want to use. Now we want to train that model, right? So we're going to load the data and call the fit method of our pipeline. That's going to load all of our existing data, look at the inputs, look at the outputs, and come up with an idea of, okay, this is the best way to process data based on past experience. We're going to save that model. That's going to create that zip file that we're going to use later, right? That's what that save method that right there is doing. It's saying, hey, go save that zip file so now I can use that in the prediction engine. Once that's saved and it's out there, I can create a predictor, create a predicting engine, and then make predictions from that model. So that's what we'll do. We'll go out here, we'll create a prediction engine, and we'll set up a test to run, and we'll enter in a couple of new values and see if it produces a result of something like we would expect. So that's what we'll do. We'll come in here and we'll say, okay, great, let's go create a class to represent some test data. So we have to add a whole new class. We'll put in our class for test data. I think we need to make it static, so we'll go and we'll change that to static. I'm going to push this along just a little bit for time. So there's our static class, and then we need a member of that class to represent the actual data. So we'll add that member. It's going to be static as well. So this is an instance of a test, right? This is basically one data point. So we'll add that. There we are. So we've got 5.1, 3.5, 1.4, 0.2. That's one particular data point that we want to then say, okay, which group does this data point belong to? What type of flower is this flower based on these measurements? And that's exactly what this example is going to pass in those values, right? So we're saying, hey, go predict based on this data, what group does it belong to? What kind of flower is this, right? That's exactly what we did here at line 26. And if everything worked as expected, it should come back and say cluster 2. That's the group it belongs to. However, I've got a couple of errors that I left in here. Number one is the data is not in the right spot, so we'll see. I'll figure that out. So, but this is good as a .NET developer. It's good to understand that as you run some of these tutorials, they're not always going to work. And in fact, a lot of my students, when they go through these, they'll like constantly get emails saying didn't work, nothing. And I try to tell folks, go in there. So, for example, I've got a using statement that I didn't need. I didn't follow the tutorials 100%. So instead of calling it what the tutorial thought it would be, I called mine flower demo. So I had an extra using statement I had to remove there. And then the next one, so I run it again, and this time it gives me a path not found. This is because, again, I forgot to put the data into that directory. So, but I want my students to understand that even though you're following the demo and you think you've done all the steps, step by step, there's room for error. And so this is how to deal with some of these things as you're debugging and walking through and figuring out. Read some of the error messages and try to think about what they're trying to tell you. So in this example, the follow directory doesn't exist. That's because I put the data in the wrong spot. So again, I'll go out to the file system here in my Solution Explorer and say, oh, okay, that meant to be in the data file. So once I've got those couple of things resolved, I finally get through and run a successful run, reads the data, and sure enough, there's group 2 based on those distances. So we got what I would consider a successful run of the tutorial. So that was using ML.NET straight out of the box, pretty bare bones, running a console app directly against it. In addition to that, you have the model builder. So what's the model builder? It's this graphical Visual Studio extension that makes it much easier to build, train, and deploy custom machine learning models. So before we did train that one machine learning model, we didn't get to try different others. This model builder uses something called AutoML, so we can actually explore different machine learning algorithms and figure out which one might be the best for our scenario. So even though the previous one, we sort of we chose one that we sort of knew would be best, but maybe it wasn't. So model builder helps us to do a better automated dynamic choice of models. And just like we saw with the scenarios earlier, there might be we might be depending, what are we doing? Are we doing data classification? Are we doing value prediction or image? So that the very first thing we set up before we even start looking at different models is we choose our scenario. So we know we're doing, in this example, we're going to do, we're looking at restaurant reviews and figuring out if they're good or bad. So let's do a quick demo of this sentiment analysis where we look at using a different tool in ML.NET, that is the model builder. So here we're looking at again, I love .NET or Microsoft Learn because it's just a quick 10-minute tutorial. It uses, again, Visual Studio 22. Got to make sure you have the ML.NET model builder installed. So go in your installation details and make sure that's checked off. If you don't have it, make sure you download the latest version. And then from there, you can create an application. In this demo, we're going to create a console app just like we did last time. But this time we're going to use the model builder. So it's going to be a little bit different. You'll see in the tooling, we'll have a nice graphical user interface where we can select different situations, different scenarios to choose from. So again, we'll go in there, we'll go ahead and create a new project. Choose our console app. Give it a name. And again, I don't follow the tutorial 100%, so I just gave it some. So you need to be aware of that. If you deviate from the tutorial, make sure you update any instructions based on that same deviation. App demo. I've got some code. What do they want me to do? They want me to right click and add. So here's where I'm adding the model builder, right? So I'm actually going out to my Solution Explorer, and just like I added a class and some other things, I'm saying I'm going to add machine learning model, right? And that's only there because I installed it. I made sure I had installed it. So now I've got this menu option. And now when I add that machine learning model, I get a nice little window that comes up and says, okay, you want to add a model. Again, very similar to if you were doing a entity framework and you're adding a database context, I'm adding a model. I'll come down here and then give it a name. Sentiment model. Then I get my nice graphical user interface. So now you can say, hey, which scenario are you targeting? And then based on that, I can choose, the length of time I want to train, look at different models. So coming down here to our tutorial and say, okay, well, which one does it want us to choose? Or I think, again, we're doing sentiment analysis. So that falls under the data classification scenario. Make sure you're using the right version. I'm going to train on my local PC, CPU. You have to choose your scenario, choose your environment, choose your data. So again, I'll choose local classification, local CPU, choose my data. I guess I could use a file or SQL Server. That's built into this model builder. And now the data, again, the data's out there on the internet. I'll go pull it down. All it is, this looks like it's from Yelp. It's the actual text of the review and then a score. So just like we did in the previous example, we're going to look at past experience. We've already got some reviews, and we already know whether they were a good review or a bad review. And then based on that information, we're going to train our model so that when we give it a new review, it will determine, hopefully accurately, whether it's a good review or a bad review. And you'll see it really depends on how much time you give this model to train on the reviews. So the less time you give it, the less accurate it'll be. The more time you give it, the more accurate it will be. So we'll go in here and go grab that data and add it to our ML app directory. We'll just go ahead and paste that in there. I just grabbed all the data. We really only need that Yelp labeled data, but I just grabbed everything that I downloaded. You can see some of the example reviews. Wow, love this place. That's a good one. Nasty was a bad one. Just like we did with the previous example, you've got columns that you need to load. So in this case, the one column is the review, and the next column is whether or not it was a good review or a bad review. So we'll go out there and find that data. There it is. There's some of the actual reviews in there and their associated scores. And again, using the GUI, it makes it a lot easier to just go out there and select the column that we want to load, where before we had to build our class and specify the different columns. Here we're just pointing and clicking. So I can say, all right, I want column 0 is the actual, or column 1 is the column we want to predict, right? That's what we want. That's what we want the model to predict, whether it's good or bad. 1 being good, 0 being bad. So we've set it up. We're looking at our data. We feel pretty good about all that. And then here comes the interesting part, where okay, how much time do I want to commit to this? Do I want the model? The tutorial says to spend 60 seconds. So because we're doing this live, we don't want to actually spend 60 seconds training our model. So I only did 10 seconds. But you can see there, it's going through the different models. It's getting a figure of which model has what accuracy based on the existing data. And then, so it only had 10 seconds to train and look at different models, but based on those 10 seconds, it came up with the logistic regression over model and said, let's try that out. Let's try that model. So now I can try it. I can say, okay, here's a bit of data from the previous results, and crust is not good. 88%, that's a bad review. That is a bad review. So not a bad job. All right, let's go. I'm going to type in a brand new one. How about food was yummy? This one's a little tricky because yummy, I don't think that word was anywhere in the and look at that. So it says 60, almost 60%. That was a bad review, which it wasn't. It was a good review. So I should give it a better word. One of the words that was probably found in the data, excellent, and it does a better job. Right now it says, oh, 63%, and that's a good review. So you can see it's not perfect, right? Using that yummy, it kind of threw the model off. I could probably go back. In fact, I did. I went and I did like a longer training, and it got better with things like that. So it is important to give it a decent amount of time to train, and obviously the more data, the better accuracy with the training. So in this example, we move on, and what have we done so far? We've loaded data, we've trained it for a little bit, we've picked a model, but now the next step is to actually use that in code. So how would you use the results of that? So what is the result of that? It is the ML.NET trained model. So you got that zip file again. And then additionally, the model builder gives you a class to consume the model, sentimentmodel.consumption.cs, and then a training class. So 3 different pieces of code that model builder generated for us. And it does give you different templates, whether you want to use it in a console app or a web app. So here's an example of using it in the console app. So literally I can create in my program sample data from the sentiment model. I give it an example test data to analyze, and then check out the result. So that's what we're doing here. We're saying, hey, go use our model, give it a column. And again, just like we did when we were evaluating it, we can run this to see if it's producing a result that we would consider accuracy. Now, again, ran into a little issue here where I named my demo different than what the tutorial said to do it, so I had to go fix that. But once I got that taken care of, I can go back out there and run my demo. And there you go. You've got this restaurant was wonderful. That's a positive result. That's accurate. So it really is an interesting and fascinating tool to use the model builder to do things like data classification and some of those other scenarios that makes it much easier. And again, looking at different models, very easy to do. So lots of great tools out there on Microsoft Learn. I can't say enough great things about Microsoft Learn. I mentioned that I've got a lot of certifications. Microsoft Learn, as well as having all these tutorials, has exam prep material. So if you want to prepare for a certain Microsoft exam, you can literally go here in any of these Microsoft Learn modules, and they have knowledge checks, which are like little exam test questions. They will even run cloud challenges where if you complete a set number of modules, you can qualify for a free Microsoft voucher for an exam. They have just tons and tons of material on not just machine learning. I mean, just all of these are popular learning paths and modules, cloud computing. It goes on and on. In fact, I've got one here that I was a big fan of. This is an introduction to machine learning, and now this particular one, while it doesn't use ML.NET, it does use notebooks, which is very popular. And I think we saw some examples in the previous talk of using Python with Jupyter notebooks to run different samples and come up with different results. So again, if you're looking to get started with machine learning, you look no further than Microsoft Learn with some of these tutorials that walk you through in a matter of minutes how to get started, learning about models, how to create the models, whether it's using ML.NET or Jupyter Notebook, and these are those kind of like knowledge checks at the end, so you can do, hey, did I really learn something? This, am I ready to take the exam? It really is a great set of free resources for anyone to use. There's also a lot of other resources out there. So developer documentation on how to, other samples and examples to do machine learning. There's a whole model builder guide that goes into a much more deeper detail of the different options and different ways to improve your models. And then there's just a ton of samples out there on GitHub where you can go out and just try some existing samples and see how, and then extend those examples and add to those examples, so you're not starting off with a blank sheet of paper. So that's it. That's a quick run through to the intro.ml.net. Is there any questions that anyone has?
Yeah, wow. We got actually holistical idea about the ML.NET, and I'm also a .NET developer, so also MVP from developer categories. So it is a really a good to know about like ML.NET has a huge possibilities, and we can use this in our .NET application. So obviously it is going to extend the capabilities of even developers to include AI features in their application. Yeah, so it was a great session, and appreciate your effort for such a comprehensive session. We learned a lot about the ML.NET. Thank you a lot, Mr. David. So I can see there are no any there is no any question. So and I think now still we have a 5 minutes for next session. So let's wait for a few minutes if we can get any queries. So anyway, if there are no queries, I think we can proceed to our next session. And yeah, if anyone has any kind of queries or any concern, even if they want to reach, then later they can reach. David has shared his contact